Has everybody got a copy of the code? Yeah, I think so. So what I'm going to do here is go through an example of a job where you take some file, split it up, do a word count, merge it back again. And I appreciate that, yes, you can do this without using Condor. It's more to demonstrate the pieces and how you fit them together. And what I'll do in this lecture is just show you doing this word counting process. And then on Thursday, we'll take the same effective bit of code and adapt it for doing a little bit of DNA analysis. Very, very simple. But it's very easy to adapt the structure to do something a lot more complicated and challenging. But I wanted to show you something that was kind of close to what you already do. Does this sound familiar, where you take some files, split it up, do something with it, and then play it back together again? So I thought it would be a nice way to sort of see the relationship between what you're used to in Hadoop and what you can do with Condor and how you would do it with Condor. So, and in most of this lecture we'll actually be going through the code, which you should have in front of you. So the task is to take a very large, it was the largest file I could freely find, WP standing for War and Peace. We will split it into 5 pieces. We will then send each of these pieces off to Condor to process, get the word counts. We'll get individual count files back for each of those 5 pieces, and then we'll merge them back together again.
But that feature is not the classes.
It is. Splitter is the first class you have there. So what you have in front of you in code, chaps have just come in. There's some lovely code for you here. Pass that. You pass that back. What you've got, the first, it's kind of in logical order. The first file, which is 1 page double-sided, is the splitter class. The next one is a thing that does counting for a given split file. The third page is a class that does merging. And then the most complex class of the lot is the very last page. It's a class called count, which has a single attribute, which is a current count. So that's what you have, and that's kind of the order in which we'll do things. Split things, count them, merge the counts. So it should bear a relationship to what you've been doing already, and I thought it would be quite useful to see how I would code it up. And as I said, we can use exactly the same structure for doing a little bit of simple DNA analysis. So what this... hang on, I'll leave that out of that. The way we do the splitting, I've got a bit of Java code to do splitting. You don't have to use Java code, you can use Unix split command, but this is a bit more controllable for us. I said, right, run the Java virtual machine with the class path wordcount.jar. Now what I have is a jar file, and inside that jar file is all these classes bundled up together as a kind of little library. So they're all sitting in there. So what I'm saying is, find this jar, and in there use the splitter class. Here's the file to split, War and Peace. You can see how lazy I was by writing WP. And in this case, split it into 5 chunks. What we'll then do is take each of these chunks and send them off to Condor and say, hey, count the word distributions in the chunk that you've got. So from this, we're going to get 5 files out. Each one of them goes to a different job in Condor. They're run, and then what comes back is lots of pieces, which we will then run a merge on. So we go again, here's the Java virtual machine, here's the jar to use with all the classes in it. This time use the merge class. It's got some arguments which we'll come to, which is basically a prefix to use. This is what we want the result to go to. And I think 50 was, don't give me anything that's got a count of less than 50. So if I've got words that occur less than 50 times, I don't want to know. But you can change that to an arbitrary one you like. Is this in any way related to stuff you're doing right now? Good. This is a little Unix command to just sort that document by column 2 so that I get the merged counts in count order, so the most frequent thing at the top. That's just quite handy. Otherwise you've got a lot of words to go search until you find out the most one. So that's your map out, process, reduce, and done. Any queries? Are we good?
What's the C9WP in the...
CP, minus CP.
Down?
That one?
No? Right?
That.
Yeah.
That is a prefix that I want this merge job to stick in front of every file that I create. It's a tag that you'll see where it comes in later on. It's just so that so it knows which files to pick. They'll all have a C-WP in front of them. It's not a specific command at all. These are command line arguments to this class. So we've got argument 0, argument 1, and argument 2. Yes, remember that args? I showed you public static void main, string args, and that's an array. So in args will be that, and that. Arg 0 is that one, args 1, args 2. This is me passing information into these jobs to say do this or that. So I'm going to... So for example, let me have a look. So here I am, this is me actually on pound. I have got my source document, in this case it's War and Peace. So shall I read through a few chapters of this first? Yes, I'm sure you'd like. There we go. It's War and Peace, and it goes on for a very long time. So that's that one. Wordcount.jar. That contains all these classes. It's just easy to bundle them all together. I have a Condor submission file, which is subcount.txt. So here we go. We're going to submit this on the Linux nodes for the Java universe. Here's the class again. Can you see how having everything in that jar? It's quite handy. I don't have to keep saying individual files. So look, it's all in there. The bit, just pull out the bit you want. Here I go saying, no, I'll come back to what's happening here in a bit, but basically I've got the counter class. Each counter is given a file to process, and it's given a cutoff, so basically saying words of length 1 or more will be counted. If I made that 3, then only words of 3 characters or more would be counted. We disregard and it. It's got an argument to say here's a file to bring over to the node. Here's a file that you're going to process. So this is actually going to be the output of our splitting effort, and then the stuff we've seen before. So the first thing we need to do before we go to Condor is take War and Peace, wp.txt, and split it. Now I'm lazy, so I've put in a shell script the command I want to issue. So this is the thing I showed you in the lecture note. Shall I just type it out anyway? Okay. So Java Virtual Machine, CP is shorthand for class path. It's telling Java where to look for stuff. You can actually write class path, but I'm just going to go CP. It's basically saying look in the following places for jars and class files. I'm saying look right where you are for word count. So in there I want you to use, from that jar, I want you to use the splitter class, and I want the splitter class to take War and Peace and split it into 5 chunks. So if I run this, it's done it. Now I go ls, I've listed the contents directory. You should now see we've got WP-0, WP1, 2, 3. So that's War and Peace split into 5 chunks. So why do you think I wanted to do that?
5 nodes.
So I can run 5 jobs on 5 nodes. We can make that 20. In theory, we should make that number, the number of nodes we have available, to be as efficient as possible. So in theory, I should have gone 700 or something. But I really didn't want to go ls and get 700 files. It's the point. I wanted to get the principle across without... Yeah, you can figure that to what you want. So we've now got these files. Now these files have to go onto each of the nodes, don't they? So I'll go and look at that submission file again. Here's that submission file. You'll now notice that each job gets a file which is WP dash and then some number, and that number is, it's the job number, isn't it? It's the between 0 and 4. yeah, which matches exactly. So each job will get one of these pulled over to. We won't copy all the chunks to all the nodes. We'll just copy across the chunk that needs to go to that particular node. I'm hoping you can see that this is the sorts of thing you would generally do, and I'm showing you this is the way I do. There's a bit of setup involved in this, isn't there? But usually with this sort of job, you're doing a number crunching job that takes a bit of effort. The whole reason you've decided to even go down this path is because it's something big, and hopefully it's something you'll be doing frequently. As we kind of go through and you get to the sort of stuff I actually use this for, you only set this sort of stuff up once, you get it right, and then it becomes easier and easier to just submit another job and another job. As long as you've designed your code right, and it can take command line arguments and you can tweak them slightly, you can get it to do very different things with actually very little extra coding. It just takes a while to set up, which is not great for me when I work with one. I mean, I have a very patient collaborator in management who I work with on one of these problems. I'm extremely patient. It takes me a while to get things going, and he just twiddles his thumbs, but once we're up, we can start punching these results out really quite fast. And it's very easy to say, well, what if we try this, or what if we do that? And it's one of the things we'll look at in an example, probably Thursday, where we'll look at the effect of mutation on the performance of a GA, what to set the mutation rate at. Have you looked at that at all, or do you just keep a fixed value? Mutation rate has a massive impact on how successful you'll be. So we can really quickly set up a job to test that and find out what should you set it at for the problem that you have. Right, so we've split our job up, now we want to submit it to Condor, so let's do that. What do I type to do that? I haven't forgotten, I'm just going to ask you. Any takers? Condor, I want to put the job out in Condor now. Submit sounds like a good bet. And then I have a file that starts this up. I'm just in tab to finish that, so let's go. Let's submit that job. Off it goes. 5 jobs have gone. I've made it 5 jobs because it needs to fit to the 5 pieces I've broken one piece into. Let's do Condor Q, and just to check for me, I'll put my initials. Oh, it's already done. So now we've got back, all being well, we've got these files have appeared. Now you can see I never specified them, did I, anywhere in the Condor job. But the Condor job ran, looked at what was new in the directory it ran in, went, oh okay, we'll give you that lot back. So
When did you set these two to the merge?
I haven't done the merge yet. All I've done is the split. I've done the split and I've said, and now the Condor job is to do word counts on each of the split pieces. You haven't merged it yet.
How did you get the C-WP?
That was written by Condor, and in fact, let's do more sub. Oops. Counter did it. Yeah, Counter did it, and we'll see where Counter did it internally. That's hardwired into the code. But what I want you to notice is we started off with these pieces of War and Peace, and now we've got counts. So if I look, I can go more C-WP. So this is the output of node 0, jobs the jobs that run on say node 0, and now we can see word counts in random order as it found them. Exciting, it only appears twice in a fifth of War and Peace. That's not very exciting, is it? No wonder it takes so long. I've not made it through War and Peace. Anybody else managed to? You have. Good effort. Have you seen that book?
I was in hospital.
Ah.
I had nothing else to do, so
Really? It's apparently very good, but very, very hard to hold all the different characters together.
Yeah.
Yeah. I'm bad enough at that at the best of times. My wife gets driven slightly crazy by me whenever we're watching a movie and I'm going, what were they doing? Where did we see? And eventually I get chucked out of the room. But there we go, you just put them there. Avail twice. So you can see there's an awful lot of words with very low counts. Yeah? So that's one piece of it. So that's us done our Condor job. I'm not arguing that in reality you would ever use Condor to just split and do merge counts. let's just imagine that the thing I analysed is a heck of a lot bigger. Yeah, maybe the file is a terabyte. Yeah, and I can split that terabyte into 700 chunks, and then put those chunks on Condor. Can you see that starts to buy me effort? Yeah.
Do you always have to split it so that it uses different nodes? Condor will do that for you, kind of like Hadoop, then you don't have to worry about it, and it just uses all the resources available. You actually have to split it into chunks so that it uses all the
You have to do everything yourself, yeah. Because Condor can do, imagine Condor can do lots of different things. It doesn't know what you want to do. It's a structure for doing distributed processing jobs, but what those jobs are.
It's like a manager of physical servers that don't really know about each other.
Yes. Yeah. Yeah. It's very much on you to decide how you want to use it, but the flip side is you can do it to do lots and lots of different things. But it doesn't know about what you're doing, whereas Hadoop has got one very specific job, which is to take a large data set, have it distributed via the file system, and then processed. But that's all it does. There's a load of stuff I can do on Condor you just can't do on Hadoop. Hadoop is very restricted. In fact, we'll come back to where the limitations with Hadoop are. But for me, it's very, it's very quick and easy for me. If I had a very large file and I wanted to make it 700, I would just do that split thing, and instead of putting 5, I'd just write 700, and then in my submission file, I would just go Q700. That's it. That's all I have to do to use 700 nodes. No extra coding involved.
You have to split the text file.
No, I had to split the text file, but it's very easy for me to do that. All I would have to do, if I wanted... Oh, your chat... Okay. No. All I'd have to do is change that to 700. Yeah? That's the bit that splits the file. And then in my submission file, I'm not going to hit return there because I don't have 700 little files. But in here, I would then just change that line there, Q5 to 700, and that's it. So it wasn't that hard, was it? I've now made proper use of 700 parallel nodes or jobs. You can have that number be much larger than the number of nodes you have available. It'll just keep batching them in until it runs through them. So if you've only got 50 nodes, you can still say Q 1000. It'll just run 50 of them at a time until it's got through the lot of them.
And if you set the queue less than the number of 5, will it send more and more files to each?
No, it will only grab, because of the way I've set this up, it's only going to send the right piece to the right file. So you need to make sure that in this example you queue exactly the same number of jobs as you have pieces.
So what's happening to the queue selection?
What I was saying is, if you only had 50 nodes available on the actual cluster, but you said you'd split to 1,000 and you'd queue to 1,000, it would just take 50 jobs at a time and put them on the cluster until the job completes, and then it would get another 50 and another 50. So you can submit far more jobs than you have cores, but that's fine, and that's taken care of. You don't have to worry about that. In fact, that is what happens. We have some students who will submit 3,000 or 4,000 jobs, research students, not undergrads. The undergrads don't get near this. We're letting you near it because we trust you. And we'll know, you can see how easy I can find out what's going on. I just go Condor_Q, and I'll know how long a job's been running for, and eventually someone will go, what are they doing? So I could mostly behave themselves. So having done our split, the last thing we need to do is take all these pieces and bring them back together again. So I can't just concatenate these together, can I? No, I can't just take that CWP0, because you can see that the same words are going to be in both, well, in all 5 files. So I actually have to read through each of these files, load them into a hash map, keeping a note of the counts, add all the counts up, and then write one final version back out. And that's me merged it. So the concatenation doesn't work in this case, but this is much closer to, I think, what you're doing. You're having to sort of get lots of pieces, count the things up, yes? Until you've got everything you want, and then write a final result out. And that's exactly what we're going to do. I'm doing this example because it's closest to what you're used to in MapReduce. My later examples are nothing like MapReduce. MapReduce just doesn't work. So to do the merge, this is what I'm going to do. I'm going to say, well, I'll write this out by hand. Java minus CP again, so that's that class path thing. Word count.jar, so that's where all my code is. The class I want to use this time, so within word count.jar I now want to use the merge class. Here, this is me telling it what the prefix will be for the files that contain the counts. So you asked about that earlier on. So I'm now telling my merge program, look for files that start with C-WP. They're the ones that contain the counts. Only load those, don't touch anything else. And then I will put the output in a file called merged, call it anything you like, and I will take words that have got counts of 3 or more. Yeah? Anything less than 3 I'm not interested in for some reason. And that's it gone out. Now what we should have is a file called merged. And here it is, but it's in random order. So apparently in War and Peace, halt occurs 16 times. Fun fact of the day. Almost as good as fun with flags. Actress only turns up 3 times. It's quite unusual. I'm surprised about that. Anyway, I'm sure you don't want me to go through. Oh, there you go. Thing 229 times in the whole War and Peace. Yeah, I'll stop now. So that's what we've done. We took a file, we split it up, we then submitted it to Condor, got a load of counts, got lots of the pieces back, merged them together, summed all the counts up, we're done. So now would you like to see the code that makes that happen? This is the bit you go, no, I'm going home now, and then that's the end of the lecture. Yeah?
Yeah. Is there any reason behind like the counted words and the numbers? Is it like some of them are placed in the left and
Oh, why are they slightly offset? It's purely, this is tab separated. So I'm printing the word and then a tab character and then the number, and it's just entirely dependent on how long that word is. So this word here, for example, exceeded the first tab position, so it ended up on the second tab position. If you were to load that into Excel, it would all line up nicely. It's just that because this one was already in, that Y sits in the first tab. You can see here there's a tab, and the first tab position on the console is right there. Well, Y is occupying it there, so it goes to the next tab position. That's all it is. Yep. Good question?
Where did you use the count class?
It's hiding deep in there. It is there. While I'm getting myself sorted out, you can find it. Yeah.
So which one is the duck work?
Oh, you'll have to wait until I finish. Until I can tell you. You'll probably guess. I think it's over there or something. But we'll come back to that. Right. So let's move on to how this is actually done. So what you've got now is just the code as we step through. I tried to comment it. I think the version you've got, let me just check. Should line up more or less with the code version. Sometimes I adjust the code afterwards, but this should be pretty much it. So here we go. Here's the splitter, the first thing we ran. We have main, get some arguments, and we basically say, make sure, have I got enough arguments? If I haven't, don't even bother carrying on. The arguments I want are a file name and the number of sections to break it into. So in the example I gave, what comes in here will be what? What was the wp.txt, yep. And I think this was 5. So once I know I've got 2 arguments in this array here, I will create myself a splitter, and I will call split with wp.txt in there and 5 getting passed in here. So here we go, here's split. So we have a file name and the number of parts. We're going to read a file, we're going to write out to a file, we're going to have lines that we're reading. We are going to have prefixes for each part of the file. So I think we had WP-1, WP-2, so that's that bit. And this just tells me which part I'm currently on. So, right. So here I go, I've got the file name. Now I want to use the file name to decide what the parts are going to be called. So I look for the dot, so that gets me the dot for d.txt. I then take everything before the dot and put it in the prefix. So in the prefix will be Not yet, no. Not yet, no. That's on we're splitting at the moment. So file name contains wp.txt, so the prefix is wp. Yeah, I thought I'd keep you on your toes, ask you the odd questions, see what's going on. So that's the prefix. Now we try and find out if that file that we've been asked to split actually exists. So we create a file. Have you come across file yet? Yeah, actually, what do you use? You do use file. You don't always need to use this, but this creates a reference hopefully to that file and asks if it exists. If it exists, it finds out the size of it. So if it doesn't exist, we bail out at this point. We say if it doesn't exist, say it doesn't exist, get out of this method. I'm returning straight out before carrying on. So I only get to this line here if that file exists. Are you used to returning out methods early? There's some puzzled looking faces. I quite like doing this. Basically, if I know I'm done, if I know whatever I want to do isn't going to work, I'm out. Yep. So, yeah, I do this a lot. I'll either have a return out. This is returning out of split saying I'm done. This isn't going to work. So if I get here, I know things are good. So now I say, right, what's the size of the file in bytes? And then I say, right, well, if it's so many bytes, 1,000 bytes, divide it by 5. So the blocks are 200. So I want 200 characters at a time in each block. Yeah?
Is that possible that you split the word so it will be a piece of word in a file and a piece of word in another file?
Yes, actually there is.
Okay.
There is, except for the fact that I'm going to be reading this. What you're suggesting is a bigger problem with my DNA analysis because there's no lines. And you already noticed, and I haven't even got there yet. With this, it's reading in the file line at a time. So unless there's a word going across 2 lines, which I don't think happens, I'm okay. But with the DNA thing is one long sequence, that is not okay. Not that I stop myself doing it. Right, so have you covered reading files in Java? I'll briefly quickly go through. This is me opening that file. This is me opening wp.txt. So that opens the files. This puts it in something that can read the file a line at a time. So in is an object referring to the stream of data I want. And now I say to in, give me a line of data. So that's one line in the text file. And now I say, if that line wasn't null, if I actually managed to read something, then I'm going to start going through my chunks now. At the start, I'll have read no characters, and I won't have a file ready. So here I go now to start writing out my counts. So the prefix part here, well, not my count, sorry, my split bit. So the prefix contains what? WP, yeah, and then the part is 0, 1, 2, 3, 4. Have you seen string.format in Java?
Roughly the same as Python.
Yeah, which is actually all comes from C. C's printf uses this format. I like it. Java got this far too late for my liking. I like to use it this way. Basically what you do is you come up with a formatted string and you put percent and some character to denote what you would like to appear there. So %s is I want a string to appear here, and %d is I would like to put a number, an integer. And then you have to provide the things afterwards, separated by commas, in the order in which you expected. If I put, so it's expecting a string and then a number, if I put them the wrong way around, it'll crash. It's very upset. In C it's printf, and I suspect everything's just nicking the idea from C. So that's going to give me a file wp-0.txt. Right, and now I've got a file name. I create a file with that name, ready to write to it. So that's a link to the file system, and this allows me to print to it a line at a time. Right, so we're in a position. We've opened up the file to split up. We've got our first part. We've opened the file to put the first part into. Now we're going to go through a line at a time, reading a line and checking that the number of characters that we've read so far is less than our block size. So in my example, my block size with 200, we'll read 200 characters worth or close to at a time. So here I go, I read in a line, I've got my line, I add the length of the line to my character count, I print the line out, I read another line. And I keep doing this until the number of characters I've read and printed out is greater than my block size. And so basically I keep going around that loop until I've written out, say, 200 characters worth, and then I say, right, that's that block done. So I close that output, I go, right, I want to go to the next, I want to write a new file, which is the next part. I've written part 1, I need to write part 2. All this is doing is splitting the file up. So we come back here, we create a new file, we come back here, we write that file into part 0. So we did part 0, now we're going to do part 1. Keep going until the block size is met, and then we go back up here. Do you follow? This is writing out WP-0, WP-1, WP-2, splitting that War and Peace into 5 parts.
So the fire are not the same exact size?
They're not exactly the same, but I don't care. As long as they're close-ish, that's fine by me. I think the last part will probably be slightly smaller, but we don't care. We just want to get it close enough. The end result will be fine, so we're good. Lastly, we close that file and we're done. So that's the splitting. Can you see how that's happened? You've already seen this. This is how we submit the job once we split it. We now want to go and count everything. So we have the counter. The counter takes that WP0, WP1, WP2.txt and counts everything in it. And this is telling it, here's the piece you need to take over and process. And we've seen the result of that. Now we need to count everything. So this is where your hash map stuff comes up. This is why you're here, as it were. So now the job I've got is I need to take each of these pieces and I need to look through them. They're just blocks of text. Actually, did you want, I suppose, let's have a quick, maybe WP-3, there we go. So here we go, here's WP-3. This is the contents of block 3. You know, we go through that, counting word distributions. So I create my counter. My counter has an argument which is the file to open to count the contents of and the size of words to discard. Anything less than, say, 2 or 3, you won't count it. So small words like an or it, I'm saying ignore them. It's up to us, we can change the specification. So that's me creating my counter object and telling it which file to process and things to ignore. And the other thing we do is we declare ourselves a hash map. And this hash map is a mapping between strings and counts of those strings. Now,
How do you divide
it's a class. Where is it? It's the last page. Now the reason for this is the way hash maps work is they have to have 2 object references, don't they? They have to have a reference to, say, the key, in our case a string, and a reference to an object associated with that string. Now you're probably mostly using it string, string integer, yeah, but you're doing capital integer, which is actually, and also that's immutable. So if you set it to 1 integer, it can't change. Now I want to change the count repeatedly, so I can't give it an integer, as in a capital I integer, full, yeah? I want to keep changing this value. I don't want to keep creating lots and lots of...
If it's an int, you can change it.
Yeah, int is not an object. I can't pass. That's the whole reason I've had to do this. I cannot put int there.
Well, even if you can
Hmm?
Remove the old one, put the new one.
Yeah, I can do that. That means creating thousands of objects and getting rid of them. So for efficiency reasons, rather than doing that, I'm creating myself a count that inside it, this one object associated with this one word.
You definitely know what you do not cache in Java because the cache collection routine doesn't run through enough code, things like that.
You'll be creating so many integer objects. This is much more efficient. and also demonstrates the idea that you can put any object here you like. Yeah? It associates that word with that object, whatever that object is. So in my case, it was simplest to just create a little count.
Is that the same then as a writable?
Yes, whatever you want to put there, you can associate anything you like there, as long as it's a reference to an object. So I'm going to associate an inside count is basically my counter, which is just an int, as you know, as you said. So what I'm going to look for are words. Every time I find a word in War and Peace, I'm going to say, right, well that word has this count, or if I found it before, I'm going to add one to its count. So we'll just quickly look at how I do that. So here we go. We've got the file. What am I doing? We've got the size of the pieces. If the number of characters is less than min count, I'm not interested in it. This is the file I'm going to read in, a reference to it when I open it. This is the name of the file that will be written to. We're going to write stuff out. The line I'm currently on and my counter. So I start by emptying my hash map. I probably don't need to do this because it should start off empty, but just to be safe, I empty it. And now I create a file where the output's going to go to. So this is C dash, and what do you think file name is going to have in it? WP. So you can see where that C dash WP turned up before? This is me producing that file. I'm saying, right, I want counts, so this is going to be C dash WP 0, WP 1, and so on. Now I start reading in my chunk. So what I've got on Condor is one of those pieces, WP-0, WP-1.txt. I've got one of them. That's what's in file name. I open it up. And then now, this is a slightly... Have you seen this way of reading lines from a file? I showed you the easier way before. Now I've actually just combined it in one go. I basically said read a line, and if you managed to read a line, as in it wasn't null, carry on. You're more likely to see lines being read like that from a file than you are the other way around, where you just say, well, line not equal to null, do something, and then you have to read another line. This is just sort of speed things up a bit. Now what I do is I take the line that I've just read from the file, it's just a line from War and Peace, I turn it to lowercase, and then I split it on any non-alphanumeric character. That's a pattern match on any non-alphanumeric character using regular expressions. That will give me, for that line, the words that turn up on that line, whether they had commas, dots, dashes separating them. So in that words thing is just an array of the words on a line all separated out. And now what I do is I go through each word I've got in that array, and I try and find out about the counts for them. So for any given word in that line, I look up that word in my hash map. And I should get back a reference to what type of object? A count, a reference to a count object, which is the count associated with this or and, or I only wish I could remember Igor, I don't know, like characters of War and Peace. They're all in there. I get a count back. Now, if I've not come across that word before, what I'll actually get back is a null. I'll ask the hash map, tell me how many times you've seen Igor before, and he goes, I've never heard of him. Yeah? So that's my clue that I haven't started counting Igors yet. So what I do is I say, oh right, in that case, I'm going to create a new count object for Igor. That's me going, he's a new count object, I've only seen him once, this is the first time I've seen him. Associate him with the word Igor. So in W will be the string Igor, and here is a count object to associate with him, which is a count of 1, because I've never seen him before, but I obviously have got him right now. Do you follow? Is this vaguely similar to what you're doing? Is it useful? Oh, good. I feel slightly guilty for having you here at 5 o'clock in the evening, so I'm hoping I'm giving you something that's of use to you. And I give you this code, you see, you're here, this is precious. It's not online, it's just here. It is done in the lectures, I guess, but it's easier to see in one go. If I have seen Igor before, in other words, this counter gave me back an object, then I don't do the bit about map.put because I've actually got a reference to an Igor counter already. I just go here and I say, right, well I've got a reference to Igor's counter, I'll add one to it because I've seen him again. Yeah? That's it. And now I just keep going around. I say, right, that's that done. I go up to this line, get a new line, split it into the words on the line, go around each word in each line, find the reference for each word on that line, look at the counts, increment them if I've seen them before, create a new one if I haven't seen them before, and I keep doing it. And once I get to the end of the file, I say, right, that's it done. I close the reading of the input file, job over. And now the last thing I need to do, well, what do I need to do before I terminate my Condor job? I'll close the file, I'll close the input file. I need to, once I'm completely finished, I need to send this out somewhere, don't I? I need to produce output, yeah?
Would it be better if you got counter.count to actually do the map.put?
I don't need to. No, I'm not putting a new object back into here at all. I asked the map for the reference to the object associated with Igor, for example. So now I have a reference to an object.
Is there a map.update button?
No, it's put. We put a new object in.
There isn't one for updating or
That you don't need to, because that's what that's doing. If you want to change it to something else, then you'd have to go .put, and that would get rid of the old association. So if I did put again, then I would put a new object in, and I'd lose the old one.
the counters point into your the
Yep.
object that you define.
Yep.
So if you created an object with two parts
Uh-huh.
and you wanted to update each of those parts, you'd have counter.count and counter.whatever the other one.
Yeah, exactly. Yeah, this gave me back the object that's associated in the hash map with Igor, and then down here I can change the properties of that object as I like, and that's fine. That object still exists. I'm not creating a new object every time. I'm good, and it's fairly efficient. It's a good question. Yep. So this is me just updating these counts without creating new ones. The alternative to do it is to create a new object and increment the count from the last one, but that's just creating more and more objects. You just want to steer well clear of that. You're writing the kind of code that efficiency really matters. You can't get away with sloppy code because you're doing heavy data processing, heavy number crunching, or just heavy computational effort. A lot of the time you'll write code, and you can write pretty shoddy code and it doesn't matter, because whether it takes 30 seconds to run or 45 seconds, you don't really care. But if a job takes 50% more time and it's already taken a week to run, and you're paying for every day.
And then if you had two parts in that counter,
Yep.
and we were trying to get value back out from the hash map, would be map.get w dot.
You could do it that way, but you're better off getting a reference to the object, checking if you actually got something back. There's no guarantee that map.get will give you back an object that you're looking for. So in theory, yes, you could do map.get w.count plus equals 1 or equals, yeah, add 1
Would
to it.
that lead you to the other?
If I did map.get w.count plus equals 1, it's the same as doing that, except I don't know for sure when I do this if I'm going to get an object back or not. So there's a great danger that if the object's not there, and it will not be there a lot of the time, it'll get a null reference problem, that you'll try and access an attribute for a reference that you haven't got, because you've never found it. So you get the reference, you check the reference is good, and then you act on it. Yeah, you should write. Yeah. There'll be many times, whenever you've never seen Igor before, that will come back null. So you don't want to be going .count for something that doesn't exist. It's good that you're asking these questions. Right, so the last thing I need to do is write this out. So here we go. This is how I write to a file. And what I can do is, so this is me writing to that count file. So this is going to be C-WP -0. It's those CP files. This is me writing one of them out, whichever job I am on Condor. I'll wait until you're back. You can see what's going on. And now all I do is I say, hey, hash map, give me your key set. Give me the set of keys. So what are those? What's the key set for my hash map going to be? It'll be all the words that I found in this chunk of War and Peace that I've been asked to process. So I'm going to go through each word I've got. And provided the word is greater than 1 and it's also greater than this minimum word size. So if the word is and, I might ignore it, but if it's oh I don't know, Vladivostok, then I will keep it because it's big enough to me to pay attention. If as long as it meets this criteria, I do, I write to the file the word, the tab character. You were asking about the tab, this is where it came from. Yep, right there, and then I write the count. So that's where that appeared from. And I just go around every word in my set in random order. You've no guarantee the order you're going to get them back from the key set. They're just in random order. I write them all out, and then when I've gone through the entire key set, close the file, and that's my Condor job done. How are we doing? You with me? Right, last thing we need to do is, once we've got all these Condor jobs back with lots of counts, we've seen our C-WPs, we've got all of them back now, we've got the result of doing all these counts, we now need to merge everything. So what we've got is this list of C-WP-0, this lot here, LSC-WP stuff. We've got these 5 pieces. We've got say 3, just all these. Right, we now need to merge the lot. And actually that's so similar to what we've already just done. So here we go, this is my merger. It has its own hash map, and the hash map is going to reference a word and its counts. And it says, here's the file name for process. Remember this right. So what was our one? Yeah, the file to send all the results to when you're done. So merged.txt we had, and then the size of words to ignore. So we did some in count thing again, and all we do is we say right. Okay, we've got our prefix. Now this is a filter. The prefix basically says these are the files I want you to pull the counts from. So our filter will have the contents of over here somewhere. Any volunteers? We've got a prefix. We're trying to get this to do counts. We're saying, right, there's a directory full of files. We want to say which of the files in this directory do we want to get the counts from. So it's just how, what do these files start with? So they start with C-WP. That's where that comes from again. So I'm basically saying, look, just pay attention to files that start with C-WP. Whatever you do, don't try and count the word counts in the jar file. That would be a disaster. Yeah. So that's that, and there's the result to save it to. So what I do is I say, right, have a look in the current directory that I'm in. That's this, and from the listing, this folder.list gives me the entire listing of that folder. All the files are in it, and they're just strings. So I go through each one of them, and I basically says, if that file name that I've just pulled from the folder listing doesn't start with a prefix, go and get the next one. Yeah. So if the file does not start with this prefix, continue. So continue just means do the for, go to the next thing in the for loop. So once we get past here, this line here, we should only have files that start with our prefix. They'll only start with C-WP. So here we go.
Excuse me,
Yep.
if that doesn't continue, does that return?
It doesn't, no, it's a good question. What continue does is continue the loop it's in. So it doesn't go below, it just goes straight back to the next item in the loop. So effectively right back here to whatever the next file is in our directory listing. I find it's cleaner to do that than try and go to the bottom of the loop and come back. The one, if you don't want to carry on, the alternative, if you want to say, right, I don't want to go on anymore in this loop, you put break. And break will not go back to here, it will go to the very end and go to the thing after the loop. But in this case, I do want to carry on looking through each of the files until I find ones that do start with my prefix. But what I do know is, if I get to the line after here, I know I've got a file that begins with my prefix. So I know it's a file that should contain counts. Now I open this file, and now I start reading lines from it. And all I have to do now is split that line. Remember I used a tab to put the word tab count? Well, now I'm going to split by tab. which should give me a string array with how many parts in it? 2 parts. The first part will contain the word, and the second will be the count. Yep. So in token 0 is the word, and in tokens 1 is the number of times it occurs, but that's a string. I have to force it into being an integer, and then I put that in my, and then I stave that integer in occurs. So word Igor occurs 3. Then I ask my hash map, have I got that word? Do I know about that word? You've seen this before. If I don't know about that word, I create a count for that word based on the number of times it occurs. So in this case, occurs could be 3. It'll be however many times it occurred in that file. So if Igor occurs in the first chunk 3 times, we get a count of 3, and then the next time round with the second chunk, we might get Igor 2. But the second time around this loop, we already have a reference to Igor, don't we? So we don't do this bit. We say, the second time around this loop with a different file, I already got a count, so actually I'll just update Igor's count. This is so similar to what we did before. You still with me? It's very, very similar to what we did before, but now instead of adding 1 every time, we're adding however many times it occurred in each of the chunks. So we just go round and round, we open a file, we find out the counts, we add the counts to our hash map, our running counts. If we don't have it, if we've never seen that word before, we create a new count for it based on how many times it occurred. And then when we're done, we do exactly what we did before, we write one final file, which is, here's the final result, go through the key set, which is all the words from all the chunks, look up words, check they're long enough for us to be interested in them, and now print the word and its summed count. So this was us doing the summed count right here across the chunks, which is a bit like what you're doing in, you probably have a reducer that's doing something like this, is that fair? Is this matching up, roughly? I've tried really hard to make it as close to what you're doing. And that's it. And that's the result. Oh, I've given it away. The excitement. This is sorted. You're very pleased to know that the turns up 34,545 times in War and Peace. And it is only 5,602 and no sign of Igor at all. So that's the equivalent. But I can use that, I can adapt that slightly very quickly to do anything I like. I was counting words, but I can do something else with those words. We're going to count DNA sequences, not today, on Thursday, with just a small tweak of that code. And you can see how looking at sequences of length 9 or sequences of length 3 tells you different things. It's the same code, it's just a minor adjustment. And there the data is a lot bigger because DNA sequences are on the order of gigabytes of data. Even then it's a trivial job for Condor. Do you have any questions? Or are you done?
Did you have to solve the hash map?
Sorry?
Where did you solve the hash map?
I didn't. I absolutely didn't. That's a great question. No, I did not. What I got out from the merge, where have I put the bit, is merged.txt. It's not sorted in any way. And I didn't use Java to do it. The way the merging was done actually is there's a sort command in Unix, Linux. You can type sort. You can give it the column to sort on. This is 2, which was the number. That does it in reverse order, so get the largest number first. Here's the file to sort, and that's the result of the sorting. Yeah. So I know I use Unix. Unix is fantastic for this. It's why we love it so much. It's got tons of really useful, very focused commands with lots of lovely options to tweak it. Why write the code when and I didn't have to do the split either. I could have done that in Unix. Yeah.
So did you have a hash map when you were trying to get the maximum output?
Yep.
And you have more records
Yeah.
that matches the maximum criteria.
Yeah. Well, you take Is this the bit where I stop recording now in case there's evidence? Well, here you're going through every word, and you can keep account of the. In here, you can say take a note of what the highest count you found so far was, and what the object associated with that was. So you can keep a reference to a count object. Say right here, you could declare before you go into the loop, largest being a reference to a count object, and then you check largest count against the current count object you've got, and if the current count object you've got is smaller than the one you've just found, then you say, right, my new biggest is this count object I've just pulled out of the hash map, and you keep going around and updating this count object every time you get a larger occurrence, and then when you get to the bottom of the loop, you know the word that's got the largest count. I'm not going to type that up on the screen. I think it would be bad of me to tell you. It sounds like that might be something to do with what you've been asked to do. But you're going through that loop and you're getting to see everything in that merged set. So you can go through and say, right, is this bigger than any other count object I've seen? If it is, it's my new biggest count object. Is that what you were effectively you were here for, hoping to see? And you can see how it's been used with my code. So as I said, on Thursday I'll show you a variant of this, which is actually DNA analysis, and hopefully you can see how generic this is. So thank you.
Thank you.